this video, we want to give an introduction to SimTalk. SimTalk is an easy-to-use scripting language which is fully integrated into plant simulation. It extends the ways you can model and control your simulation. Each object has built-in properties providing many useful features. However, when your model requires more detailed or completely different properties, you can program these in the programming language SimTalk. To build our own program, we can use method objects from the Information Flow tab. In the method object, we can write code, which is executed during the simulation. To do so, insert the method object into the frame. You can build your own programs using a combination of built-in methods, keywords, assignments, and control structures in the method. The first concept we want to introduce are variables. Variables are used to store data. In SimTalk, a variable is an abstract container for a value that occurs during the execution of a computer program. Variables have a name, a value, and a data type. We will look at a first example where we create a variable. To create a variable, we need to use the keyword var, which stands for variable. Then we need to give the variable a name. We will name our variable length of object. To assign a value to variables, you can either use the equal sign or a colon in combination with the equal sign. These variants are used in common programming languages. Plant simulation offers both possibilities. So we insert an equal sign afterwards and assign the value for. Variables have next to a name and a value, also a data type. In programming, variables are assigned different data types as defined by the values they can take. There are many kinds of data types for variables. However, you do not have to specify the data type of a variable when you immediately assign a value in the declaration of the variable. The data type is then automatically derived from the value which you assign to the variable. In our current example, the data type integer is assigned to the variable. The integer data type represents a positive whole number or its negative value. The second data type we want to introduce is string. Strings are used to represent text rather than numbers. We again create a variable which we will call example text. When creating a string variable, we need to insert quotation marks around it. Into the quotation marks, we type Hello World. The third data type we want to introduce is Boolean. The Boolean is a data type that has one of two possible values, true and false, which are intended to represent the two truth values of logic and Boolean algebra. We create a variable, isFull, and assign the value true to it. Then we can also use the data type length. For our created variable length of object, this would be more convenient than integer. If we leave it like it is now, plant simulation will interpret the variable length of object as an integer. However, if we insert a m for meter after the value, plant simulation will interpret it as data type length. These are some of the data types used in SimTalk. However, there are further ones which you can look up in the help. What we want to do next is to print the created variables. Print means that we want to output the value of the variable to an interface. This interface is called console in plant simulation. The console shows information about actions which plant simulation executes. By default, the console is hidden, so we need to show it first. We can do this by switching to the window ribbon and clicking on Show Console. Now the console will appear in the lower section. Then we need to enter a print statement into our method. The print statement outputs any number of passed values into the console. You can enter any number of parameters separated by a comma without any type constraint. We will print the variable length of object. But we also want to provide more information. Therefore, we first type in quotation marks the length of the object is. Then we insert a comma and type the name of the variable. Before running the method, we first need to save our changes. In the title bar of the method, we can see a star. This star indicates that we have made changes to the method and did not save the changes yet. To do so, we can simply right-click in the method and click on Apply Changes. We can also switch back to the Edit ribbon and click on Apply Changes, or use the shortcut F7. To run the method, we can right-click the method object and click on Run, or we can also right-click in the method and then on Run, or use the shortcut F5. Now we will see that the print statement is executed. Now we also want to print the other variables we have created. Therefore, we insert 2 more print statements. However, as you can see, in the console is still the output from the previous print statement. To clear the console, we can simply right-click the console and then select Clear. Now we again run our program after saving the changes. As you can see, the 2 other variables are also printed. You can also use arithmetic operations. We will create a second variable which we will call width of object and assign the value 2 to it. Now we will print the product of the length and the width. For multiplication, we use the star. For division, we use the slash. You can now either directly insert the arithmetic operation into the print statement, or you can use a variable in which you first store the result and then print this variable. We will do both. So first create a variable which we will call result of multiplication and assign the value of the multiplication of the width and the length to it. As you can see, variable names might be long, and therefore Plant Simulation provides auto-completion. Auto-completion completes the word automatically if you have entered enough characters to disambiguate the term. Otherwise, a list will be displayed in which you can select one of the matching terms. So now we again insert 2 print statements. In the first one, we will print the variable result of multiplication, and in the other print statement, we will perform the arithmetic operation. In the first print statement, we now just type until the first O. As you can see, now a tooltip is shown which tells us that we can use the auto-completion by pressing Ctrl and the spacebar. So we use that to spare us the typing of the rest of the variable. In the second print statement, we just type the letter L, and then we again press Ctrl and spacebar. As you can see now, a list is shown of possible matches. You can also see of which data type the corresponding suggestion is. From the list, we now select length of object. Then we type a star for multiplication. After that, we just type the letters W and I. Now you again see that the auto-completion suggests us the width of object variable. We now do not want Plant Simulation to again print the commands above, since we have already printed them. Therefore, we can use toggle comment. In plain words, when using comments, you basically deactivate a piece of working code. So we comment out the 3 print statements above. To do so, we can select the 3 lines and click on Toggle Comment. Now all 3 lines are commented out. If you have a single line of code which you want to comment out, you can also simply insert 2 slashes. We then clear the console and run our code. As you can see now, just the wished print statements are executed. Now we insert a conveyor into the frame. If you want to access the conveyor, to for instance query its length, you need the path of the conveyor. Objects can be either accessed through their relative or absolute path, which are pointing to them. The relative path starts in the frame in which the method object is located. Since the method object is located in the same frame as the conveyor, the relative path of the conveyor would be just the name of the conveyor. So if you are in the same frame as the object you want to reference, then you can use its relative path. So when we want to assign to our variable length of object the length of the conveyor we inserted, we can access the conveyor by its relative path. To do so, we can simply drag and drop the conveyor into the method or type the name manually. Objects in plant simulation have attributes. While variables are not associated with any particular object, attributes are specific to an object and are used to store the state or data of that object. An object can have multiple attributes. Attributes can only be accessed from within the object they are associated with. So if we want to access the length of the conveyor, we need to first access the conveyor, which we already did through the relative path of it. If we want to access attributes of objects, we use the dot after the path. However, we do not know which attribute corresponds to the length of the conveyor. Therefore, we open the dialog of the conveyor. Here we now see the field length. We then click on the question mark and then in the field. At the bottom of the box, we see the SimTalk reference for the length. We can now simply use this to access the attribute length. A second way to access the attributes would be to right-click on the conveyor and then click on Show Attributes and Methods, or simply click F8. In this window, we can now see all attributes of the conveyor. Here we could search for the attribute length. What we can also do is to use auto-completion after the dot we inserted by simply pressing Ctrl and the spacebar. We now comment out all print statements except of the one which prints the variable length of object. Then we also clear the console. Now we save the changes and let the method run. As you can see now, the length of the inserted conveyor is printed. Now we duplicate the conveyor from the class library and rename it to Custom Conveyor. After that, we open the dialog and change the length to 9. Then we create a variable which we call length of custom conveyor. Now we want to access the length of the newly created conveyor to assign it to the variable. However, we do not want to insert the conveyor into the frame. Here we can now use the absolute path of the conveyor. We again simply drag and drop it from the class library into our method. As you can see, the path looks now different. The absolute path starts with a period standing for the class library, followed by the name of the folder. Then a period and a name alternate until you reach the desired object, which again is preceded by a period. Now we have the reference to the conveyor. We then insert a dot and can again use the auto-completion to select the length. Now we add a print statement which prints the variable length of custom conveyor, clear the console, and let the code run. As you can see, the length of both conveyors are printed. Keep in mind that after the method has run, you can no longer access the value of the variables that you have declared in the method. If you want to store the value permanently and use it after the method has run, you can insert a variable object into the frame. After inserting, we rename the variable object to custom variable. Now we drag the variable object into the method and assign the length of the first conveyor to it. Now we save our changes and let the method run again. Now, even after the method is executed, we can see and use the value of the variable. Lastly, we want to introduce control structures. Plant Simulation provides templates that can be used. You can find them in the Edit ribbon. The first control structure we want to use is the if-else template. So we select it. What we basically want to do is to check if the length of the conveyor is 9 meters. If this is the case, we want to print custom conveyor. If this is not the case, we want to print other conveyor. So after the if, we need to insert Boolean condition. You can hover over the tooltip condition to get additional information. Here we want to check if the variable length of custom conveyor is equal to 9. The result of this operation will be either true or false. So we first insert the name of the variable. Then we insert the equal sign. The equal sign can also be used to make comparison next to assigning a value. So if the variable is equal to 9, then the program will enter the first branch. So in this branch, we print custom conveyor. The else branch will only be executed if the condition after the if statement is not true. So here we print other conveyor. Now we save our changes, clear the console, and let the code run. As you can see, the corresponding branch was executed and custom conveyor was printed. Now we insert a second method object into the frame. In this object, we want to show another control structure, which is called for loop. The for loop can be used to comfortably iterate a range between a start value and an end value. The loop declares a loop value. This is the first variable of data type integer. The loop variable is initialized with a start value. At the end of the loop variable is automatically increased by 1. The loop is executed as long as the loop variable is less than or equal to the end value. Keep in mind that when the end value is less than the start value, Plant Simulation does not execute the loop at all. We then define a variable, which we will call number, as loop variable and initialize it to 1. The variable should run until 10. Currently, the loop variable is increased at the end of the loop. However, keep in mind that you could also let the variable decrease. You can achieve this by inserting a down 2 instead of the 2. If the variable is between the start value and the end value, it should execute the statement print number. If we reach the end value, the for loop is exited. Now we save our changes, clear the console, and let the code run. As you can see, all numbers from 1 to 10 are printed. The last control structure we want to introduce is the while loop. We therefore build a simple model which will consist of a source, a conveyor, and a store. Then we insert a method and rename it to transfer to store and insert a while loop. The while loop works similarly to the for loop. It executes the instructions several times as long as the condition is met. Plant Simulation checks the condition before each loop iteration. What we now want to do is that the parts on the conveyor should be transferred to the store as long as the conveyor is not empty. In the loop condition, we need to insert a Boolean expression. The conveyor has an attribute which is called empty. This is a Boolean expression which is true if the conveyor is full and false if not. We can find this attribute by simply selecting the conveyor and pressing F8. Then we can enter the letter E. Now we can see the attribute and its current value. As you can see, it is currently true. So to access the attribute of the conveyor, we need to first access the conveyor. To do so, we can use its relative path, since the conveyor is in the same frame as the method object. So we drag and drop it into the loop condition. Then we use the dot to access the attributes of the object. Then we can type empty. Since we want to execute the loop statement as long as the conveyor is not empty, we insert a not in front of the loop condition. Now we have finished the loop condition. In the loop statement, we want to move the part that is on the conveyor to the store. So we need to first access the part that is on the conveyor. We again insert the path of the conveyor and open its F8 dialog. If we scroll a bit down, we can see that there is an attribute which is called cont. This attribute returns an object. To be more specific, if you use this attribute, you will get the object that is the closest one to the exit of the conveyor. This can be a part, a container, or any other object. In our specific case, we will get the part that is on the conveyor. So after conveyor, we insert a dot and then cont. Now we want to tell the part that it should move to the store. So we now need to search in the attributes and methods of the part for a method which will do this. Therefore, we switch to the mobile units in the toolbox. Then we right-click the part and select Show Attributes and Methods. Here we now press the letter M and see the Move method. The Move method has two optional parameters. The first one is a destination and the second one is a position. Keep in mind that as always you can get further and more detailed information in the help. To get more detailed information about a specific attribute or method, you can simply select the method and press F1. For now, we will not go into further detail, since we have a separate video about methods, which we recommend you to watch. We are just interested in the first parameter, which is the destination. As parameter, we want to pass the store to which the parts should be moved. So we close the dialog and insert a dot after cont, and then type move. To pass parameters to methods, we insert brackets after the method name. In this brackets, you can now insert the parameters. We will again use the relative path of the store. Therefore, we simply drag and drop it into the brackets. Now we save our method. Then we start the simulation. As soon as the conveyor is full, we can start our method. However, we will start the method in the debugger mode. The debugger helps us to debug methods and controls. To do so, it provides a couple of commands. To start the method in the debug mode, we can switch to the Tools ribbon and click on Debug, or can also simply press F11. When we run the method in the debug mode, a debug window will open, which provides a couple of commands. However, we will focus just on one, since there is an entire video on the debugger that we recommend you to watch. The command we need is step over, which corresponds to the shortcut F10. It executes the source code of the method one line at a time. We can now also simply hover over the loop condition to see the current result. Here we can see that the condition is evaluated to false. But since we have a not in front of the condition, it will evaluate to true. So if we press step over one time, it will enter the loop statement. Now we first hover over cont. Here we can see that cont is evaluated to part 1. If we hover over the first part on the conveyor, we can see that this is the first part. Now we again press step over. And as you can see, the part is moved to the store. Now we can perform step over steps until the loop condition is no longer evaluated to true, which is when there are no more parts on the conveyor. This concludes the first introduction to SimTalk.